Okay, so this unit is called radicals. So this here, the nth root of a number a, can be written as a radical expression, nth root of a. So this n is called your index. Let me get the red. It's called your index. This here is called your radical. And the a is your radicand. Radical, we use that word a lot. Radicand. Okay, if there's no index, if there's nothing written there, like for example on the warm-up, what's assumed to be, what number is assumed to be there? Anybody know? No?
1,
2. It's assumed to be a square root, so it's a 2. So we assume that it is a 2. We do square roots so often that we just have a shortcut. We assume it's a 2 if there's no number written in there. Okay, I know that up until this point, all you've seen is square roots. Going to be some other roots. Okay, anybody still looking at this here? Okay, so we want to take the 4th root of 8. So up until this point, you've seen only square roots, unless you saw it maybe in Algebra 1. So the 4th root of 80, we're going to simplify that just like we would on the warm-up. We're going to make a factor tree with our 80. What's the number that goes into 80? 10 and 8, 2 and 5, 2 and 4, and then 2 and 2. So this is the 4th root. So this is going to be a hard thing for you. You're used to just writing the square root. You're not used to writing this number here. So from on these today, most of them are going to be a number in there. So this is a 4th root. So we put a 4 there. And so then we're going to take 1, 2, 3, 4 2s and a 5. So instead of looking at groups of 2, instead of looking at pairs, we're going to be looking at groups of 4 because it's a 4th root. Okay, so we're going to circle a group of 4. So just like when we had a pair in there and we were doing square roots, we pulled one out. We're going to pull just one out and the other ones die. So this is 2 times the 4th root of 5. So if we say 4th root Jill, then a lot of them die. 3 out of the 4. Yeah. So you can only take it out if there are a group of 4, then you're only going to take 1 with that 4. If there was another group of 4, then you take 2 of them out. Does that make sense? So this is our answer, 2 times the 4th root of 5. So notice this. I put this 4 kind of in between there. Frequently, this is what will happen. What does that look like? It looks like 2 to the 4th, doesn't it? So we don't want that. We want that 4 inside your radical. Does that make sense? Okay, new to you, so you're just learning it. Okay, so 108, we want to take a 108 on number 2. And what's the number that goes with 108?
54.
Yeah. So I think you were thinking it was even. That's why you're thinking of a 2 in there. That's what I would think too. So 2 times 54. And then 9 and 6. 3 and 3. And 2 and 3. So this is the cube root of 1, 2 2's and 1, 2, 3 3's. So this time we're looking for groups of 3 because it's a cubic root. So we're going to circle the 3 3's, and then what do we put on the outside to simplify that? 3, just a 3. Cube root, don't forget that cube root, and then we have 2 times 2, which is 4. Okay. Do you have a question? Okay, number 3. So this time we have a negative on the inside. So I'm going to do something else before I do that. Say we took the cube root of 8. We want to take the cube root of negative 8, sorry. 8 is 2 times 2 times 2, right? So this would be the same thing as the cube root of negative 1 times 2 times 2 times 2. So we have a group of 3 2's. What do we do with that negative that's on the inside? So if it was a square root, it would be an I. But now it is a cubic root. So if I took negative 1 and multiplied it by itself 3 times, would it be a negative 1? Negative times negative times negative, what is that? It's negative, isn't it? So I can take out a negative 2 on this one. My answer would just be negative 2 because this is a 3 here. Okay, so now let's go back up and do this one. What goes into 320? 32 and 10. 2 and 16. 4 and 4. 2 and 2. 2 and 2. So I have 5 times the 5th root of negative 1 times 1, 2, 3, 4, 5 2's. And then multiplied by, this gives me 2 times 5, actually 6 2's. 1, 2, 3, 4, 5, 6 2's, and then a 5. So I'm looking for groups of 5. Do I have a group of 5's, 2's there? Yeah, so let's see. There we go. So now I can bring this 2 out. So it's 5 times 2. Can I do anything with the negative? Can I bring that out? If I take negative 1 and multiply it by itself 5 times, what do I get? I get a negative 1, don't I? So I can make that negative on the outside on this one. And so then this would be square root 10. So negative 10 square root 10. So what's that? Why negative? Yeah, I just leave it as a negative 1 just to make it clear rather than putting a negative there. So, oh my gosh, I forgot that. Thank you so much. You want a good job. Yeah. And that's 10, negative 10, 5th root of 10. So what's my pattern with taking out the negatives? I could take out the negative when this was a root of 5. I could take out the negative when it was a root of 3. Would you say, Dexter? When the root is odd, you can take it out. So for a 2, that's an even one, so I can't take it out when it's a 2 or a 4. It's when it's an odd number, 3, 5, 7, and so on. Okay? Okay, go ahead and do the you try, please. You're doing number 4.
What are the numbers?
I don't get one. So 75 comes in what? 11? So 5 goes after. That one goes after. No, it's not. Go get one. She got this.
Don't be bad,
She got it. She got it first. So, yeah. She's like stuffing.
Oh, I'm sorry.
Yeah. But it's just one. Okay, so you should get a 35 times the cube root of 7. Questions on that before we move on to the next one? Because the next one gets a little harder. What's happening on the next one? There's variables, okay? So what's the number that goes into 48? This group back here. Good. Okay, hold on. Hold on. Okay, so now we're going to find the factors of 48, and we did a factor tree, so that's the cube root of -1 times 1, 2, 3, 4 2's, and then 1, 3. So we have a group of 3 what? 2's. Thank you. And we want to write the x's also in there, x times x times x. So we have a group of 2's and we have 3 x's also. Does that make sense? That makes sense why I wrote x times x times x? Okay. So the 2 and the x go on the outside. What do we do with the negative? Yusuf, what is going on? What do we do with the negative? Okay. Put it on the outside. So -2x, and then we have the cube root of 2 times 3, or 6. No x's left on the inside. The negative we pulled out because it's odd. Does that make sense? Since it's negative on the inside, we put a no because. We're not going to give you ones where it's even. It's only going to be ones where, unless we're doing stuff with I. Okay, so I'm going to skip to the next one. Anybody still looking at this one here? This one here. What's the root assumed to be? There's nothing there. It's assumed to be a 2. Okay. So I'm not going to finish that one. I just wanted to talk about that. If you see that, nothing there, it means it's a root of 2. So let's go ahead and do this one here. So we're going to take 250 and find the prime factors. What's the number, this group here? What's the number that goes into 250? It ends at 0, so that means what goes into it? When it ends in 0. 10, that's right, 10 and 25. So then the 10 would be 2 and 5. And then 25 is 5 and 5. So this is -6, cube root, 3 5's, 1, 2, 3 5's, and a 2. So we're looking at groups of what? This group here, group how many in a group? 3. Yes, because it's a cube root. Good. So now we're going to take that 5, bring it to the outside, -6 times 5. Oops, I forgot my variables. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. We have groups of 3. Yeah, we have a group of 3 U's. And how many groups of 3 V's do we have? 2 of them. We have one here and another one here. So it's going to be 6 times 5 U V squared, because we have 2 groups of the V's. And then cube root, what's left inside there is 2U squared. So it would be -30 UV squared times the cube root of 2U squared. Would you like me to do another one, or you think you're good? Some people say they're good. What do you think? Okay. Okay. Will, would you pass out the worksheet for me?